Hello guys, so welcome to the second video where we are going to discuss the modeling part of NX. What we are going to do today is in this video we will try to cover all the three aspects which I'm going to discuss today. The one is we'll try to model 3D model this particular drawing which I have downloaded. The second one is this one. So what is the difference between first and the second is this is a normal extrusion option which we'll use here. The second model which I'm showing here will try to use the Revolve option in NX. The third one which is a bit complex compared to the first one and the second one, which we'll cover in the second part of the modeling tutorial. So what in this video what we'll cover today is the first and the second modeling option. Now if I go to if I try to explain you, so this particular 3D model we are going to build today. Now how I can build is, if you see the cross section, I can go from bottom side, I can go from the bottom side or I can start from the top side. So I have two options. As I said, I can start building my model from here and I can start building from the bottoms up, or I can start from the top and I can go down till the bottom. You can see certain steps which are mentioned here. So what we'll do is, first we'll model this. In the second step, we'll model this particular area. In the third step, what we'll do is we'll model this particular area. Got it? We'll check after building whether any chamfers or any fillets which are mentioned here, whether we are missing anything or not. So if you see, this fillet is being mentioned here, so this fillet is being mentioned here, that is our 1.5. For this particular drawing, we'll use the inch unit. We'll not go with the metric because these areas are very small, and for the tutorial purpose it is good if we have a bigger area. So we'll be using the inch. Now if I go to the second one, that is this is comparatively very easy, but we'll understand how the extrusion works. So if I try to explain you how the extrusion works is the Revolve option, I beg your pardon, the Revolve option works. So we understood how the extrusion works in the first thing. Now we'll see how the Revolve option works. So what happens, we have a center axis. Okay, I try to I'll do it in 2D and then I'll show it in 3D. And we have certain cross section, a simpler cross section, maybe like this. Okay, so this is my cross section. Now what this the Revolve option does is, it revolves this particular cross section in required degree. So in our case, we are going to revolve in 360 degree. So what happens is, if you see in a 3D format, we have this kind of a cross section, we have modeled it. Okay, now what we are going to do is we are going to revolve it in 360 degrees, so that what we'll get is a cylinder. Okay, so we'll get a cylinder like this. So why this is used? Why we can use the extrusion option here as well, where we can start from top or the bottom and we can build this modeler, but it becomes very easy when we are um, you know building uh, the these kind of cross sections using the revolve command, where what we have to do is we have to just I change the color. What we have to do is we have to just build this particular cross section, and the rest is done within a single command. There is no need to use anything else. So we'll start. We'll discuss how the third model is built, that we can discuss in the second part. So it is part of our second modeling tutorial part of the video. So we'll straight away jump into NX. I have already opened NX. It's been running here. I'll go to new. I'll generate a new project. It will take a bit of time. Okay, as I told you, we are going to build this model in inch. I'll define the library where I'm going to save my models. So I'll choose this. What I'll do is I'll name these things as simple model. It's fairly simple name. Just give it a bit. Okay, so it is opening. So what we are going to discuss, or what we are going to build is this thing. Now how we can build is it is fairly simple. We have distances that are being mentioned. We have radius values that are being mentioned here, R22. Then we have R17, then we have R14, we have R11, and we have R26. We'll start from the R22 here. So I'll explain it to you how it is going to be. We will ignore for the time being the bottom side of it, this particular thing. Sorry. So this particular thing, we are going to ignore the bottom side of the whole thing. We're going to ignore for the time being. So what we are going to build right now is we are going to build these two things first. You're getting it? We are going to build only these two things. Now, what is the value? We have to understand the drawing first and what is the value of it. So the inner one, the ID side, is constant throughout. There is a hole where the ID side value, the dimension, is constant. What is that dimension is? It is R11. For our reference, it is R11 inches. The radius is R11. The next is R14. That is the outer side of the first one. And how deep is it? So it is 3.5 inches deep. The next thing below that, there is another cylinder. What is the dimension of it? So it is 5.5 inch deep, and its OD side is R17. So that's how we are going to build it. So we'll start. We'll go to NX. I'll start sketching over it. Okay. So I'm going to sketch on the XY plane. What I'm going to do is I'll either click on the circle option, or I'll simply click on enter O. That will give me the okay. So what I have done right now is, for reference, I have built two circles, which are the inner circle, that is my R11, and the outer circle, which is my R14. So what I'll enter here is R14. So this particular dimension box gives us two options. We can enter the value in radius or in diameter. So for our reference, we are only entering it in radius, so we'll go with the radius. Now if you see, we have gone out of the space, so we have drawn circle this much, and now the whole drawing is out of the space. So what we can do is we can hold the Control and F, which will fit all the things. So now you can see the difference. It is a driving dimension. I'll change the background first. Okay, so if you see, this is a driving dimension because it is being highlighted in kind of a bluish color, and the inner circle is in grayish color, which is not a driving dimension, so this can be changed anytime. So as we know, it is R11 here, so I'll go here, I'll check it as the radius, I'll enter R11. So that much thickness we have entered. What I'll say is, I'll say finish sketch here. It will automatically take me into the XY plane where we have started. Now we'll see the extrusion option, how we can extrude it and which direction we are going to extrude it. We have, as I told you in the last video, we can enter into extrusion option by clicking here, or directly we can enter X, which will give us the extrude option. We have briefly discussed in the last video how the extrusion works. So similarly, first what we'll do is we'll select the sketch. Okay, after selecting the sketch, it asks us to specify the vector. Many times it automatically takes the vector. Sometimes, if not, we can define the vector. Now the automatic direction what it has taken is on the upward side, but as discussed, we are going to build in this direction, that is from top side to the bottom side. So we have a top down approach, not the bottoms up approach. So what we'll do is we'll change the direction of this. There are two ways to change the direction of the vector. You can come here and you can click, it will automatically reverse it, or you can come here and you can double click it, which will do the same thing. So what depth we are going to extrude it into? We are going to extrude it by 3.5 inches. Okay, so we are going to extrude it into by 3.5 inches. We'll see this Boolean option in the next extrusion when we are doing for the bottom side. So for time being, we'll say okay. Now the next thing is, from this surface, on this surface we have to create a sketch which will get extruded on the bottom side. So what we'll do similarly, now we had the plane over here automatically defined by the coordinate systems, that is XY plane. Now instead of selecting a plane, what we'll do is we'll select the already existing surface, the face of that extrusion. So it will create a dummy plane over there. We'll click OK. There are again two options. We can create a circle. The older one, which is where we can come here and we can select the edge. That will create automatically, it will create a circle with the diameter 28 or radius 14 dimension. Or there is another option, which is if you click on the more sketch curves, we can select the project curve. What it does is it projects the curve on the existing extrusion which we have done, or on the existing 3D model. So once we click OK, now it has converted into a sketch. There is no need to generate a new sketch. It has already extracted the sketch from the existing model. Now the only thing we have to do is we have to generate the outer side diameter, that is R17. So what we'll do is we'll click O. Automatically we can put 34 here while we are drawing, so there is no need to separately do that. We'll say finish or Control Q. It will finishes the sketch. Now if you hover over it, what it does is it shows you the active sketch or the sketch which are drawn in single stretch. So this is my sketch, this is my sketch. Now what we have done is, now we have generated a sketch which is interdependent on the previous extrusion. For example, if I need to measure the value of this particular, sorry, if I have to measure the dimension. What it is 28 inches. Now let's say I go back to my previous sketch and I enter, instead of 14, I'll enter 15. By 2 inches we have increased the diameter. I click OK. If I go back and if I check the diameter, it has changed the diameter to 30. But oh, wait for a bit. What has happened to the sketch? Now if you see, this particular sketch was an extracted curve from this extrusion. So what do you think? The diameter of it would have changed or would have remained the same? Think over a bit. Pause this video, think for a bit, and then come back. So if I click on this, what I get is dimension of that curve has also changed. So we have generated a dependency on the previous sketch. So it is good sometimes that if certain things changes in the sketch, the whole other sketch also changes. It is good sometime, or sometimes you want this particular feature to be independent of the other stuff on the 3D model. You can do that as well. So you can independently create a sketch and then you can extrude it. That way you'll be independent of the feature. So I can go Control Q or finish the sketch. I can click on X. Now previously we selected the arrow, the vector direction, so it is going on with the same direction. Now what is the depth? How deep we are going? We are going 5.5 inches deep. So that I'll enter here, that is 5.5 inches. Now the Boolean operation will check here we'll keep this particular boolean option as it is. I'll say okay. Just a bit input. Okay, I'll say none. Yeah, and then I'll say okay. So it has built it. Now if you go here and if you hover over solid bodies, what you'll see is this is a separate body and this is a separate body. So there is no dependency on it. So what happens is if you have be like this only, you have not united these two features, and if you have kept the feature like as it is, and if you go and you want to edge blend it, you want to blend these edges, what happens? Have a look at it. So it creates a blend on the inner side. You'll not be able to create a blend on the outer side because these two features are not united together. They are not a single feature, they are two separate features. So what we have to do is, I'll show you two ways again. We can do while we are extruding the second feature, or we can do it with a separate boolean command. So here what we'll do is we'll go with unite command. So it asks us to select the body. In our case we have only single body, so it has automatically selected that particular single body, and we'll click OK. Just a second, it is giving me error. Unite. I'll select this body. Okay, something is not correct. I'll go and redraw it. Something must have happened while I had changed the dimension. So I'll redo it. I'll select the curve again. I'll draw again. The circle, I hope it is 34, it is something, yeah. So I'll again extrude it. I hope this time I don't get that error. It is 5.5. I'll say unite. I'll say okay. The tool is completely outside of the targeted body. Okay, I'll say none. Let's see. This is somehow not working. I don't know. Let me check. Okay. I am completely sorry about it. I have messed up the drawing. I must admit it. So instead of taking this curve, I'll just hide it. So instead of selecting the sketch, I have to select the inner side of it. So I have to select this particular thing, and then if I extrude the thing, okay. Now if I go and say unite, it will unite it. Sorry, my bad. So if I go to solid body now, it shows these two as a single body. Now let's say we have not united that. I did a control Z. I can go here, there is another option, unite. I can select on the first body, and then I can select on the second body, and I can say okay. What it has done is it has done the same thing. It has united it, but it is always better to do it in while you are extracting certain sketch. So that is always a better thing. How to check if we have the single body or not? We can do the reverse thing. Now we can see if you enter the fillet option here, it has generated the fillet on the desired direction and not on the inside. So that means we have done it correctly. That is a very good sign that we are going good. Now the outer we have finished till here. Now we are going on the outer part of it and the bottom side of the last feature. The radius of it is 22.5. Okay. So now in the next sketches, what we can see is we'll see reference curves, how to generate reference curves while we are drawing things, or we are sketching it. Okay. So just mind that we are going to generate the whole bottom side in the drawing, and we are going to extrude that. We'll make an extrusion of it. Again the same thing. We'll go and hit sketch. We'll sketch on the bottom side of it. It has reoriented automatically itself. We are going to go and hit on the project curve. We'll select the inner curve as project curve. We'll right click it and we'll say orient to the sketch. So what it does is in the plane where we are drawing the sketch, it will reorient the whole sketch to that particular plane. If we have, let's say we have rotated it and we have to go back to it, we can do right click on it and say orient view to the sketch, or we can simply hold shift and then click F8. It will reorient it. So these are simple shortcuts. Now what is the outer circle's diameter or the radius which is given here? It is 22.5. So we'll draw it. It is 22.5 into 2. This is my diameter. I'll say okay, I'm done with it. Now the next thing, they have given a reference radius here, that is 26. So there are 4 circles, okay, which has the radius of 2.5 or diameter of 5, and the center lies on the 26 radius circle. Okay, we'll do that here. What we'll do is we'll create another circle. Now this circle is only for a reference. It is not going to be part of our actual drawing. So how we can convert, or how we can say that it is a reference curve or a reference sketch. We don't want to be part of the final sketch. You can select it, or you can right click on it, and there is option convert to reference. It has converted that particular sketch into a reference sketch. Okay, now next thing is we have hole. In our case it is a circle which has 2.5 radius, and there is another circle which has 6 radius. So what we'll do is we'll go back here. Okay, before that we'll click on finish. We have to save whatever we have done right now. So we'll click on save work part only, which will save our model. Now we are good to proceed. We need to go back to the sketch. What we'll do is we'll double click on it. Okay, now we have to draw 2 circles. One is on it has to be on the reference curve. So anywhere, there is no need to be like we have to draw at certain location or something kind of that. Make sure that it doesn't auto constrain it. So here it is taking the a tangent to the other circle. Just make sure you're not doing that. We have the diameter of 5, and there is another circle which has a diameter of 12, and we are almost done here. Now what we have to do is we have to understand that either what we can do is these particular 4 features of circles or the holes, they are at 90 degree from each other. They are 90 degree apart from each other. We can do that. We can take a reference curve here which is 90 degree, and then we can, I'll show you that option as well, but that we are not going to use in our drawing. So what we can do is we'll take a curve here, we'll take another curve here which is, and we'll make it as we'll make sure that this curve and this curve, this curve and this curve are 90 degree apart. So they are apart. We'll trim this particular curve because we want the end of it or which is on this curve. So we'll trim it, T, and we'll trim it. Now we'll select these 2 things, and we'll come here, which gets to convert these 2 particular things into a reference curve. And then again we do the same thing. What we have done here, we can draw 2 circles, one with diameter 12, one with diameter 5. We are not going to use that option. We are going to use a simplified option, which is patterning. So what we'll do is we'll click on the extended menu, we'll click on the pattern curve, we'll select these 2 curves. Instead of linear, we'll click on circle. We'll specify the center where we want to do that thing. We have the center defined. Then count and the pitch. So pitch will be 90 degree apart from each other, and there are going to be 4 features. Specify the point. I'll say it is inferred point, and it is 0, 0, 0. So that is going to be my point. And what it has done is it is featured that particular curve 4 times, that is 3 times including its own 4 times including its own feature, 90 degree apart from each other. I'll click OK. Got that? And now I think I'm good with all the things. Yes. And now if you come to the drawing, what you'll see is there is R7, that is a fillet. What we can do here is we'll trim this particular feature, so that we have only outer thing. Okay, and the magic, I just forgot to do that. So we'll click on T. This is my parent feature which we have patterned out 4 times. We'll click on it. If you see, all the other 4 things also got patterned out, and we just make sure that these we have auto dimensions. What we have got, we will make sure that those are converted into a driving dimension, so that it will not get changed. Now what will come here is there is a fillet option. You click on it, we'll click on the first, we'll click on the second, and we'll say the radius is 7. I hope you get that. We'll click on this, we'll click on this, the radius is 7. Now we have got fillet. We don't want the inner curve, so we have trimmed it out. Okay, my bad. We have to trim out this particular curve on the forehead. Now you must be thinking that why it has not done that for all the 4 features. The parent features were this radius, this circle, and not this particular inner circle. We have not made any changes to our parent feature, and that's why those changes did not reflect on the pattern feature. Now, we earlier did the constraints, but now it is showing that the sketch is over constrained. So we have given already constrained, so the sketch is already constrained, but we have given some extra dimensions which are not necessary. So what we'll do is, so it is showing in red, so what we'll do is we will select these 4 dimensions and we'll simply delete them. So now it has become a fully constrained feature. Now we can do that. We can select the first curve. We'll go for fillet with radius 7. We'll select the first curve. We'll select the second curve. We'll get a fillet. We'll get a fillet. That is better thing to be done. So once so we can extrude this feature as it is, and once the extrusion is done, we can fillet that. There is that option available to us as well. So what we have chosen is we'll do it while sketching only. So we have the bottom feature available to us now, and how deep it is. So it is 3 inches deep. We'll select the feature, we'll click on X, and we'll mention that it is only 3 inches deep and it has to be united with the previous features. So it has united itself with the previous features, and we are missing something. The fillet is given here on the bottom and the middle feature, which is our 1.5. So as I told you, I'll show you the fillet feature, how it works. It is our 1 point, my bad, it is 1. Sorry, we have to select the edge, and it is 1.5. It is 1.5, and if I show the view the results, it will be like this. So we have finished with our sketch. Just a second. Okay, something is not good. Something is not good. I'll orient it to the So my scroll option is not working. I think I have to restart NX. There is some bug, I suppose, and we have the whole feature available to us. So we can do is, I told you, Control W. Okay, something is not right. I'm not able to select certain options. What I'll do is I'll save this work part and I'll simply restart NX. I'll exit on this. I'll come back and come back. I'll launch NX again. Yeah. So I'll show you how to hide the sketch and only reflect on and see the 3D model. So I'll simply click on it. It will open my model as saved previously. Okay, that is working. Yeah. So sometimes some bug comes into NX which do not allow us to do certain things, which is like in my case, it was not allowing me to scroll, or which was not allowing me to open certain options. So you can just simply save whatever you have done, and you can reopen or relaunch the application. What I'll do is I'll click on Control W. It will give me a window which is a show and hide window. Now what it does is it allows me to show certain things and hide certain things, like sketches, datums. If you have certain constraints in assemblies, we can hide them and show. It is very handy. So instead of selecting one by one, what we'll do is we'll go to sketch and we'll say hide all the sketches. We want to visualize only the 3D model which is available to us. Okay, so this is my 3D model which is available to us. So this is how it looks like. If you want to compare the 2D cross section which is here, the 2D cross section, it is very simple. You can go to view. So whatever you have to visualize, the view option is there. So you can click on view. You can say edit section. It will give you automatic section. So you want section in the Y plane. In the Y plane. So this is my section. I'll go into display action, not the section curve, and I'll say show section curve previews. So it will show me the sectional curves. Sorry, it will I have to copy the section, save a copy here. So if I go here, if I click on F8, it will show me the section. I can do is I can hide the whole solid bodies, which I'm left with this section. And how to check that whatever dimensions we have taken, they are correct or not, and how to whether we have taken correct dimensions with reference to the drawing which is available to us. We can simply go to analysis. We can click on measure distances. Now we can measure from center. So from center till here, it is 11 inches. So ID is 11 inch, that is correct. Then it is 14 inch, that is my this particular radius, that is also correct. Then it is 17 inch, that is also correct. And the last radius is 22.5 inches, that is also correct. Now I have to check the fillet. I can come here, I can say simple radius, I can click on this. It gives me that it is 1.5, and if you go to blueprint, what it shows it is 1.5. That means whatever we have done is correct. I can go back to the solid show and hide menu. I'll click on show the solid bodies. I'll close it. And I'll go back to view, and I'll switch off the clip section, which will give me the 3D model. Now I can check the other things which I have not checked in the cross section. So I could not check this particular blend, this particular radius, and the outer radius. So that I will check. I'll click on it. I'll choose diameter, or I'll choose radius. So what is the radius of this? It is 2.5. It is correct. What is radius of this is 6. That is also correct. And what is the radius of the blend? It is 7 inches. That is also correct. So we are good to go. we have modeled the first model tutorial, and if you want this particular cross section, you can keep it. So what it has done is it has taken the cross section and it has converted into number of curves, or you can simply go here and hide those curves. So they are not, these are not sketches, but these are curves. So you can hide those curves, or you don't want them, you want those curves, and if you want the next time you can generate them, you can simply delete those curves. So what you can do is you can go here in the selection filter, you can go at the curve option, you can select those curves, and you can simply click on delete. So that has done that. One last thing which you can do, you can change the color of the 3D model. Okay, so how you can do that? You can select the solid body and you can either right click and go to properties, or edit display, or you can select it and simply hold the control button and the J button, it will pop up the edit object. Now in that you have certain object, you can control the translucency, the opacity that you can do, or you can simply change the color. You have a wide variety of colors which are available. So for example, I want to select let's do this. So okay, so what it does is enabling translucency degrades the graphic performance. You can use preferences visualization performance to evaluate the graphic performance. Would you like translucency to be enabled? So what it says is, if you enable the translucency, there will be some graphics issues, and if you want to visualize them, you can go to this preferences into visualization performance option and you can check it. So what, for the time being, I'll say okay, I'm okay with that, so I'll say okay. So now the model color has been changed. Where this translucency and the edit option or changing color is helpful is in cases of assembly. So where we are assembling features and we want to visualize with different small parts which are available to us, and we have to visualize this part goes into this and this is separated from the other component. So in that cases, if the 3D models have different colors, it is very easy to visualize that. Okay, so that is there. Now we will go to our next thing. I'll simply close it, or I'll keep that open. I can do that, there is no need to close it. So I'll create a new. Let me check whether we need to go in inches or okay, so in this case we will go with the metric thing. Okay. So again I need to save in my directory. That's a simple Revolve. Okay, so as I told you, instead of I need to revolve this particular cross section. I'll draw the cross section and then I'll do the revolve option. So instead of drawing the sketch on XY plane, what we'll do now is we'll draw the sketch on ZY plane, the ZY plane, so that we are still revolving, or we are still aligned with the Z axis. Okay. Yeah. So what we'll do is, so why it is important? It is important because if we keep the axis aligned to Z, let's say this particular simple revolve model is going to get assembled with the simple model. So while assembling those two different models, there is no need to rotate the model or align that, but the two axes with each other. The model is already aligned to z-axis, the other model is also aligned to z-axis, so we can simply put them together. One step is less for us while assembling. So to make our assembly easier, we have to keep keep this thing in our mind. So as I told you, I have selected the ZY plane. Now in that I have to draw the cross section, so the only cross section. So how will I start is I'll keep this thing side by side. Okay, so this makes the things easier. Okay, you can still reduce it, there is no need this much space to be available. Okay, so what I'll do is instead of drawing the whole thing one by one, there is another option where we can draw continuous curves. Okay, so there is this option where we can draw profile. So instead of drawing one curve at a time, we can simply go with the continuous curve option. So what I'll do is I'll click here. So for time being, I'll refer my right hand side view to my left hand side. What is the length? Okay, so I'll show you how we are going to draw it. Just give me a second, I'll attach the tablet. Yeah. So how we are going to draw it is so we'll start from this direction. We'll start from this direction, and this is we'll go in this direction. We'll draw the first line, then we draw this line, then we'll draw this chamfer, this line, this feature, this, then this, then chamfer, and the final line, which will complete our whole profile. So that approach we are going to use it here. Fair enough? Yeah. So we'll start. We are going to draw a line first, which will be 36 mm. Okay. Now the beauty of this continuous curve is there is no need to every time enter into the tool. Where it has ended the line, it automatically connects the next line. Whether we want a flat line or the horizontal line, vertical line into some angle, that we can do. So what is that? So okay, so we have to find this dimension. How will we find this dimension? Is the diameter is 32, the inner diameter is 24. That means 32 minus 24, we get 8, and it is a diameter, so we have to divide it by 2, we'll get 4. So it is of length 4. So we get that 4. Now the next thing is it is 2 inches, 2 mm, and the angle is 45 degrees. Sorry, my bad. So it has to be 135 degrees because it is on the bottom side. So it is 2, and the angle will be minus 45, let's say. Yeah, so it gives me the same thing. Okay, we are done with it. Now the whole length of this feature is 12 mm. Now they are not given as a continuous thing. So what we can do is, instead of drawing the line from this, we can draw the line from the upward direction or the upward curve, and we can simply trim it. So what you get is this. The next thing is, we have to go a bit inside on the left hand side, but how much? 36 minus 32, that is 4 mm, and we are drawing on only one side, so that is 4 divided by 2, that is 2. So we have to draw a 2 mm line. Okay, so we are good with that. What is the length? It is 4 mm. So on the vertical downwards, it is 4 mm. Now again, from 32 we want to go to 44. So 44 minus 32 and divided by 2, that is 6 mm. So we want to go in this direction by 6 mm, that is 6. Now how deep it is on the downward direction? It is only 8 mm. So we'll click on it, we'll say 8 mm, we'll say OK, we are good to go. Again we'll come back and it is 6, so we'll click on it again, we are good. How deep it is? It is 3 mm, so we'll go deep as 3 mm by 3 mm. Now again, what is the difference? Again it is same. So how we can do is, we can directly enter the value as 2, or you can simply go here on the right hand side. It takes reference that you have to align this particular end of the curve with the vertical line which is already above, and you can see this dotted line which is auto generated, that is only for reference. We can simply click OK. Now how much deep you have to go? There is no need to think upon it. You can simply draw a curve here and a curve here, and you can trim that, and once you have trimmed that, you can go to chamfer and you can chamfer that with 2 mm. So that has created chamfer. So we have two different ways of chamfering it. You can directly generate a curve which is 2 mm, or you can directly chamfer it. Okay, so you can do that. So that is that. Now we have made a bigger mistake. While drawing, we drew the curve on the center. Instead of that, if we would have drawn it away from the center, like 12 mm away from the center, that would have helped us. But no worries, we can generate a reference curve. We can take this, we can convert into a reference curve, and what would be the distance from the center? It would be 12. Okay. So instead of doing that, we can do as we can draw the whole curve, the drawing itself from the center away. That would help to draw one less sketch. So now in our case, we have to draw one more sketch, which is this. and how far it is 12 mm away from the center. So we'll go to extrude option and we'll say revolve. So it asks us different options. What would be the curve, what is the axis, and what is the center point. So specify point usually takes automatically, but we can define that. So I'll say this is my curve and this is my vector. What it has done is it has rotated the whole section by 360 degree. We have option that instead of 360 I need to rotate it only by 180. That would give me this kind of thing. You can say instead of 180 I need to revolve only by 270, or you can say 359 also. So the control is in your hand. So if you go beyond 360, so there are some people who ask that why need to enter 360 more than 360. You can enter 400 also. What would happen? It will not take, because the circle completes from 0 to 360 degrees only. Beyond 360 degrees there's no meaning to it. So we are good. We have sketched the whole thing. We revolved it around a center axis. So I'll tell you how it works. So why we have revolved. So we have selected a center axis here. We made the sketch. And we revolved it around, as I told you in this particular example which we have given. So I have generated that 2D sketch, and 2D sketch is revolved 360 degree. We generated the 3D sketch. I'll hide the sketches so that we'll be able to visualize the 3D model better. This is what we have got. Now in practical, we'll not be able to manufacture exact curves, so some chamfers would be definitely given to the manufacturing drawing. So manufacturing drawing is different from the design drawing. It would have certain things which are specifically relatable for manufacturing that particular component. So in the edge blend, what we'll define today is, we'll say that only 1 mm of or 0.5 mm of edge blend has to be given, because we'll not be able to manufacture exact corner. So we'll select 4 of this and we'll say okay. So we'll have something like this. So it is more practical and that can be manufactured. So there we go. So what we have seen today is, we have seen two different things where we generated this particular 3D model with help of extrusion commands, and this particular model with the revolve command. So the other model, which is a bit complex when compared to the other tools, the third modeling will be covering into the next part. It is part 2 of our modeling tutorial in NX. Thank you. Keep learning, stay focused, and do like, share and subscribe this video.